Alright guys, welcome to Math 171. This is our first lecture. We are going to start off today by talking about graphing by point plotting and basic functions. Alright, so let's start off simple. Okay, what is this? We've seen these forever. These go way back. This is a number line, right? It's a way for us to sort of visualize a number. For instance, if I have this point here, I'm going to do this in pencil because I'm going to erase it in just a second. If I have a point here, right, and this is our x number line, then I have x equals 2. So now, let's say I rotate this guy and I put a second number line going this way. This is called the coordinate plane. And it really is just two number lines, one on top of another. So this number line is going to represent y, and this one will still represent x. Now, instead of only being able to store one number, we can store two numbers. We could still have x being 2, but we could also have y being 3, right? So here we have x is 2, y is 3, right? So here x equals 2, y equals 3. And how can we write this in a more compact way? Well, typically we represent points in the coordinate plane by x and y. And here, x and y is, again, x is 2, and y is 3. So we identify points here, right? This is a point in this form, x, y. Something else to note here is how we can look at different parts of this space. So, for instance, if I'm looking at this line here, every point on this line has what in common? Well, this is 1, -2. This is 2, -2. This point is 4, -2. This point is -3, -2. So all of these points have y equals -2 in common. And these are all of the points in the entire coordinate plane where y is -2. We could do the same thing with x. Let's look at this line here. Every point on this line has what in common? Well, let's look at a couple of points. This point is -3, 1. This point is -3, 3. This point is -3, -4. This point is -3, 0. Every point on this line has x equals -3. And these are all of the points in the coordinate plane where x is -3. This line is the x-axis. And this is where, this is kind of counterintuitive, what do all of these points have in common? We've got 0, 0, 1, 0, 2, 0, 3, 0, 5, 0, -3, 0. This is where y equals 0. The y-axis, what do you think that is? Well, that's this guy. What do all of these points have in common? This is 0, 1, 0, 3, 0, negative 2, 0, negative 5. This is where x equals 0. So it's a little bit counterintuitive, right? But the x-axis is where y is 0, and the y-axis is where x equals 0. All right, let's draw another graph here. Or sorry, another coordinate plane here. Sometimes we string many, and in fact infinitely many, points together to create a graph. So for instance, let's say we were looking at something like this. This is just a collection of a bunch of points. All lined up. Kind of looks like a necklace. So some of the points that we have here are this guy, 0, 0, maybe this guy, 1, 1, this guy, 2, 4, this guy, 3, 9, and then this guy, right? Negative 1, 1, this guy, negative 2, 4, and this guy, negative 3, 9. Right, we have a bunch of different points. Those are just a few of them. Often we can summarize these points with a relationship. Here we have the relationship y equals x squared. For instance, let's look at x equals negative 3. If x equals negative 3, again, our relationship is that y is x squared. X is negative 3, so we have negative 3 squared, which is 9. So that gives us the point xy negative 3, 9. If x is 0, then we have y equals x squared, which is 0 squared. 0 times 0 is 0, so we have the point xy equals 0, 0. If x is 2, then y equals x squared, which is 2 squared, which is 4. xy, in that case, is 2, 4. Every point on this graph is going to follow this relationship. That's what this graph represents. And that is what we're going to look at in the graphing by point plotting exercise. So here in explaining the exercise, I'm going to work on some of the more difficult ones so that when y'all are working on it, it's kind of more straightforward, but you still get to see what's going on with these more, I would say, interesting functions. The one I would like to start with is number 5, f of x equals 1 over x. In the lab manual, you have this table, and the table says x, and then f of x, and then x, f of x. Now, f of x, we can sort of think of it as y, so that's what we're doing here. So this is a point. So we're kind of going to do exactly what we were just doing, right? Which is picking an x value and figuring out what f of x is, and then finding the point, and then we're going to graph it. So I'm going to draw my graph over here. So let's let x be -3, right? We're going to move from left to right. You don't have to do that, but that's how I'm going to do this. So starting at -3, I want to know what f of x is. Well, if our relationship is 1 over x and x is -3, then I've got 1 over -3 or -1/3. So my point now, right, x we're replacing with -3, and f of x here is -1/3. So I can go ahead and graph that on my coordinate plane. Okay, so -1, 2, 3. So I know I'm looking here. And then -1/3. So that is, we're going to look, we want it to be about 1/3. So we've got -3, -1/3. All right, let's do another x value. Let's look at -2. Again, my relationship is 1 over x, so I've got 1 over -2, which similarly to this one above is going to give us -1/2. So our point here is -2, -1/2. So -2, -1/2. We want it to be about halfway there. Okay. We can do -1, 0, 1. Let's do -1. 1 over -1 is going to give us 1 over -1. 1 divided by 1 is just 1, right? Anything over itself is just 1, and since that negative can come out front, we just have -1. So our point here is -1, -1 here. All right, let's look at 0. So what happens when I divide by 0? Can I divide by 0? I cannot divide by 0. That's one of those special rules of algebra. This does not exist. So the function is undefined here. So there is no point, right? And it is undefined at x equals 0. Interesting. Okay, let's look at 1. So if I divide 1 by 1, again, we can simplify that to just plain old 1. So we've got the point 1, 1. Next, we've got 2. When we plug that into our sort of relationship here, we've got 1 over 2, which is simply 1/2. So we've got 2, 1/2. So we want this to be about 1/2 here. And if we think about it, so we are sort of seeing this relationship where if we have 2, we've got 1/2. If we have 3, we've got 1/3. 1/4, right? It's going to sort of keep getting closer and closer to the x-axis. now let's see what happens when we get into this area, because this is looking really funky. All we know is that we're undefined at x equals 0, so we don't have any points on the y-axis where x equals 0. What's going on in here? Well, we can check any of these x values, right, between 0 and 1. So let's say we're checking maybe 1/2. What happens when I plug in 1/2? Well, I'm going to be looking at 1 over 1/2, or 1 over 0.5. If I plug that into a calculator, or I simplify this algebraically, I end up with 2. So I have 1/2, 2 here. 1/2, 2. Let's put something bigger in, and let's see if it's the same when it's negative. So let's say, let's do negative 1/4. So I plug that into this relationship here. We've got negative 1/4 underneath, or negative 0.25. Plug that into a calculator, I end up with negative 4. So that's 1, 2, 3, 4, negative 4, and 1/4 is really, really close to this y-axis. So we are like here. So if I'm connecting these dots, again, we know that we're going to get really, really close to the x-axis over here as our x values get really small. And then looks like we've got some sort of similar thing going on here where we're getting really, really close to the y-axis. And same thing here. Looking like that. Oops. This is the graph of the function f of x equals 1 over x. I didn't necessarily expect y'all to know that it was going to look like this, but we're going to talk a lot about what's happening here and here in a couple of days. Other one that I would like to go over with y'all is number 9, which is f of x equals log of x. This one is one that we definitely are going to need calculators for. Make our table I'm going to start with actually -1 here, and you'll see why in just a second. So I want to find log of x here. So that means I'm looking for log of -1. So that's something that I need to plug into my calculator. Log of -1, close the parentheses. So this gives me an error, right? If I try to take the log of -1, it gives me an error. We're going to learn more about this in a little while, but that means that this does not exist. So this is undefined at x equals -1. Let's try 0. If I go to, or if I calculate log of 0, again, we have an issue, right? Domain issue. Does not exist. We are undefined at x equals 0. All right, let's roll the dice again and try +1. If I take log of +1, I get 0. Great, so I have my first point, and it's 1, 0. So let's go ahead and put that on the graph. One, 0, I'm here. Let's try 2. So if I put log of 2 into the calculator, I get a crazy decimal, which is totally fine. 0.301, etc. Just going to round it to 0.301. Generally for WebAssign, you're going to want to, whenever you round stuff, round to at least 3 decimal places. That will make sure that your answer isn't counted incorrectly for a rounding error. So that means we have the 0.2 and then 0.301. So we graph that to 0.301, that's probably about right here. We do 3. Let's do log of 3. We've got 0.477. So we're about here-ish, kind of close to half. If we do 4, 5, 6, etc., we get pretty ugly numbers. I'm going to throw in some math teacher knowledge and say, let's try 10 so that we get a nice number. If I take log of 10, we end up with 1. So we have the point 10, 1. That is, unfortunately, I planned really, really poorly off the graph as we have it. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm kind of fudging, but we've got that point there. Now, again, that doesn't really tell us much about what's going on here. We know that we don't have any points over here because we had does not exist for these guys. So let's try something that's in this sort of range here. And again, I'm going to throw in some nice math teacher knowledge and say, let's try 1 over 10. If I take log of 1 over 10, I end up getting -1. If I put in 1 over 100, I get -2. And now, last but not least, let's say we're looking at 100, just to sort of round it out and see really what's going on here. So log of 100 is 2. I'm sure this doesn't make a ton of sense right now, but when we talk about these types of functions, we will discuss this more and why it looks like this. Let's go ahead and graph these points here. So we know that 1 over 10 is going to be -1, so that's already, as it stands, pretty close to the x-axis at -1. Then we know then we know if we put in 1 over 100, that's very, very close to the x-axis. Really, it's going to be hard for me to draw it that close in a way that makes a lot of sense at -2. So we know that this is getting bigger as we move off in this direction, but really, really slowly, right? The time it takes to reach 2 is going to take until we're at 100, which is just all the way over there, right? So this graph here is going to look like this. Again, we'll talk more about what's going on with this, but that's what number 9 looks like. So what types of functions are these? This 1 over x function, we're going to learn more about this, but this is what's called a rational function. Some properties of rational functions are that they do this weird thing where they are sort of leveling off, right, in different places. Again, we're going to talk about this really, really soon and give that a name. But for now, just know that rational functions sort of have this type of situation going on. Logarithmic functions can easily be identified by their function, right? It has this log, which is short for logarithm. Again, this is a logarithmic function. And they are sort of characterized by having this sort of sideways J shape, sort of flipped and tilted J, but it's kind of a J, right? Where we have this kind of curve and then we get really, really close to the y-axis here. Logarithmic functions don't have anything going on for all these negative x values. So on this left side of the graph, we have nothing going on. That's a good tip-off that we're dealing with a logarithmic function, is if we have nothing going on and then we get really, really close to this y-axis. These are just 2 of the types of basic functions that we're going to talk about this semester. To see more about these basic functions, you can check out the Desmos activity that's listed in Blackboard. That does a great job of explaining all the different types of functions. That's all I have for this first lesson. Again, welcome to Math 171, and I'm excited for this semester. Thanks, y'all.